All right, first let's look at the intended effect. What we want is if we go into a rendered mode with lights and shadows, that the model is always fairly well lit no matter what the angle is. Now if you look over on the right side, you'll get an idea of how this is achieved. The camera is over here behind her. There's an empty over here. The camera has two lights attached to it. The empty has two lights attached to it. And there's a fifth light that is right above her head here. This light only just follows her rig. So if I grab her rig, you can see that light above her head is following that. It's actually following, if we click on it, we can see it is actually following the focus empty. The focus empty is where the camera is focused. I place this right between her eyes so that whatever pose she's in, wherever she's going, then it's focused right between her eyes. So let's zoom back out so we can see what's happening here. So again, what we're looking at is this empty behind her and this camera in front of her. As I spin it, you can see there are the lights. Essentially, they look like they're all following or related to the camera, and they are to some extent if you follow up the parent chain enough. All right, so let's look at how all this is achieved. So this, what I call flash light, is parented to the camera. If we look at this, I call it cam with flash is the name of this camera. So this flash is parented to it, so that if I move the camera, this moves as well. Then the same thing with this one down below. So this is a kind of a kink. I forget the names of lights. I'm not a lighting expert. So a light from below, which is smaller and generally less powerful. A light from above, which is bigger and more powerful. Then there's this empty behind her, and by behind, what does that mean? It means it copies the location of the cam with flash, all three X, Y, and Z axes, but the X and Y axes are inverted. So that means that as this camera moves away from her, the empty also moves away from her, but in the opposite direction and closer, closer. So you can kind of watch how that works. And if I pull far enough away, then it kind of helps you notice that these two lights back here are actually children of this empty. If I grab that empty and say, move it, you can see these lights follow along. The lights have some extra constraints on them, which we'll look at here in a second. One of the other tricks about this is if I, again, go in rendered mode, you'll notice she's not darker than she was before. She's the same light, and it's not because of this light above her head. If I move that away, you can see she's still roughly the same exposure here. And the reason for that is these flash lights have on them a driver for their power. And if we look at the expression for that, it is, I've pressed the wrong thing. All right, let's back up here. We've got this, so now I can click this again. So the driver has a function, or has this formula, POW focus dist plus 0.5, comma 2 times 5 times flash bone. Okay, so let's pull that apart and understand what that is. And both the flashes have a very similar formula for them. So let's edit this and take a look. So what is the focus dist? Focus dist is a distance. That's what this thing is here. It's a distance between these two objects, the cam with flash and the focus. And so currently it's at 4.3 meters. And so we just take that, add half a meter, square it, multiply this by 5. Okay, so what are we, right, multiply that by 5. That's the basic formula. The only extra thing I've got going is this thing with flash bone. Well, what is flash bone? Flash bone is just one of the bones of her rig, and the Z scale changes it. So what I can do is be like, well, I think the flash is too bright, so I can go into her rig, back up. There we go. Go into her rig and grab this bone, and its Z scale will increase or decrease the flash brightness. So if I make it super small, that's what it looks like with no flashes. You can see it, she's pretty dark. But what that formula then does for you is the closer the lights are to her, the more dim they are, and the further away they are, the brighter. So if I look right now at this light here, its wattage is 172, right? But if I start pulling in, you can see that power is going down, down, down. Now it's only 50 some odd watts. And as I mentioned, I've got the same formula, or a similar formula, I should say, for this one down here. The difference of this is I just want it to be less bright. So that one, the big one has a times 5. This one only has a times 3. So basically, this is a 5 out of 10. This is a 3 out of 10 in strength. So there's more light coming from above than below. The lights behind her, if I remember right, I don't drive those. Oh no, I do drive those, and it's probably going to be the same thing, except I don't care about the flash bone in this case. So now let's figure out how these lights in the back work. Their placement is weird. So the lights that are attached to the camera, they just follow the camera exactly. The lights on the back do not just follow the empty. They do follow the empty, but they have some extra constraints, because if I had them just follow the empty as the camera got super close to her, the lights would pull all the way around front. You'd have 4 lights shining on her front instead of just 2. So what I do with those is I have what I'm calling avoid camera. So what I want is when the camera is really close to her, I don't want these other lights in the back coming around and getting close to the camera. So they are forced to stay 3 meters away. So this is an outside distance. I forgot the name of the constraint. Anyway, it's essentially makes sure that it's always going to be at least 3 meters away from the camera. But also I want it to stay near this empty. So if I just have it staying away from the camera, sometimes what can happen is it can pop all the way around behind the camera and do some crazy stuff. So I want it to stay close to the empty that it's parented to. So that's empty, named empty. Let me just double check, make sure that's correct. Yep, it is. So it needs to stay within 3 meters of this empty. That way, if I zoom all the way in on her, you can see that, this light is not popping all the way around, and it's staying within 3 meters of the empty. I want it to stay above the ground, so what can happen is if I move the camera down, the empty also moves down. The empty is moving. Its rules are, recall, it is following Z, not inverted on Z. So as the camera moves down, the empty moves down. And so what could happen is these, if I didn't have that forcing it to stay above ground, is it would follow that empty and go underground. So I don't want that to happen. And then the track 2, I have on all lights. Every single light I have tracking to that focus empty. So if I take this focus empty and highlight it, which I can't do from the viewport, I can only do from the outliner. Anyway, so if I grab that and move it, you can see that everything's kind of following this here. All the lights are pointing at it. And then remember, this light above follows it as well. It doesn't just point at it, also follows it to wherever it goes. The other thing is, it's not clear from this, but that also affects the focus of the camera. So if I move that focus empty way over here, then she gets quite blurry over there on the left, and move her back, and there we go. So I can kind of be like, decide where I want the focus to happen. And like I say, generally I just leave it between her eyes, because generally I like to have the face in focus, and specifically eyes in focus. So I believe, let me do a really quick inventory here. I've talked about this light. This other light I believe has roughly the same constraints as this light over here. I avoid the camera, I stay near the light empty, and I stay above the ground, and I track to the focus empty. So exactly the same constraints. Let's just go ahead and click this and make sure we got it. So this does also copy the rotation, inverting on the x-axis of the camera. I'm forgetting exactly the reason I do that, but feel free to experiment with that and kind of figure it out. So one thing that you might want to know is, like, what does this look like if I detach the camera, right? So let's make this view not be a camera view, but instead just be a regular 3D view. So now if I'm rotating behind, the camera is staying here, the lights are staying there. So now you can kind of see that there are different angles where the lighting is different. So the point of this is that if you set up the lighting some way you want on your model, say you want the light coming mainly from the right and mainly from the top, and then you want to spin the camera around it slightly, and you want the light to just basically follow that. Essentially you've composed how you want the lighting to be on your model already. You don't want to have to recompose every time you spin around. Like, you might be like, oh, I want to get a view from here and up close. Okay, well now I want to get a view from here and far away, right? No matter how I do it, the lights are all roughly correct with if I do this camera view. And so let's go back to the camera view so we can kind of see that. Come far away, she's lit up nice and bright. Come in close, she's not overexposed. She's actually all right. There are some problems. This is one of the reasons why I have that brightness bone in her rig, because if you do come too close, the formula stops being correct, and she can get a little bit dark. You might want it to be lighter than this, or other way around. Maybe you just don't like how bright it gets from far away, but tweaking the formula doesn't work for you, so you've got a bone you can tweak to kind of change all that. And I believe that'll do it for the lighting rig. So hopefully this helps you out, and happy lighting, happy blending.